All right, let's get right into it. We're going to talk about something pretty fundamental today. We all know these AI models are incredibly smart, right? But how do they actually do anything in the real world? On their own, they're just code. They can't interact with anything. So how do we get them out of that digital box and make them useful?
The best way to think about it is like this. An AI model is this brilliant, powerful brain, but it's stuck in a jar. It has no idea what the weather is today, it can't check your calendar, and it definitely can't fire off an email for you. To do any of that, it needs eyes to see what's going on and hands to actually take action.
And that's exactly where agent tools come into the picture. They are, quite literally, the AI's eyes and hands. These are the external programs, the functions, that finally let that brain in the jar see and do things. We're talking about fetching data from a website, or pinging a database, or calling an API. These tools are the bridge between the AI and, well, everything else.
Okay, so you'd think, great, just give the brain some hands and eyes. But it's not that simple. Not at all. Because when you start trying to connect every single tool out there to every single AI model available, you run into a huge, messy problem. It's what you might call an integration nightmare. And this nightmare, it actually has a name. It's called the N times M integration problem. Super simple concept, really. N is just the number of AI models you have, and M is the number of tools you want them to use. The problem is, for every single one of those pairings, a developer has to sit down and build a totally custom, one-off connection.
And just look at how fast this spirals out of control. You've got 10 models and 10 tools, and bam, you're suddenly on the hook for building and maintaining 100 unique connections. It's a massive bottleneck for developers. It just doesn't scale. No way. So to fix this absolute mess, a new standard started to emerge. And you can think of it like a universal translator, a single, elegant protocol designed to let any model talk to any tool without all the custom wiring.
So back in late 2024, Anthropic introduced something called the Model Context Protocol, or MCP. The goal was to create a universal plug-and-play interface for all these AI tools. Honestly, the best analogy is a USB port, right? You don't need a different cable for your mouse, your keyboard, your hard drive. You just plug it in and it works. That's the dream for MCP.
So how does MCP actually bring some order to all that chaos? Well, its setup is beautifully simple. First, you've got the host. That's your main AI application. Inside the host, there's a client that speaks the MCP language, and that client talks to a server, which is where all the tools actually live. It's clean, it's modular, and it's standardized. Problem solved, right?
Well, here's the twist. By creating one universal way for everything to connect, MCP also, unfortunately, creates one universal way for things to be attacked. This really elegant solution kind of opens a Pandora's box of brand new security risks.
See, the basic protocol is missing some things that big companies absolutely need. There's no solid, standardized way to handle authentication. It's often really fuzzy whether a request is coming from you, the user, or from the AI agent itself. And there are no built-in ways to log or trace what's happening, and you know what they say, you can't secure what you can't see.
So let's look at a really specific threat this creates. It's called tool shadowing, and it's a pretty insidious attack, where a malicious tool basically disguises itself with a clever description, tricking the AI into picking it over a safe, legitimate one.
Look at this. On one side, you have the good tool. It's very specific, very careful. But then you have the malicious one. It uses these broad, tempting trigger words like save, store, or keep. The AI, just trying to be helpful, could so easily get tricked into using the malicious tool, and just like that, it sends your sensitive data straight to an attacker.
And this leads us to another classic vulnerability, one that's been perfectly updated for the age of AI. It's called the confused deputy problem. This is what happens when a program that has a lot of power and privileges gets tricked into misusing its authority by something or someone with way less power.
Okay, so picture this. You've got an AI assistant, and it's connected to your company's private code repository through an MCP server. Now that server has been given really high-level permissions so it can do things for employees. It's the powerful deputy in our story.
Now, an attacker who has very low-level access comes along and writes this prompt. It seems totally innocent, right? They're not hacking anything directly. They are just asking the AI, the confused party in all this, to do a couple of simple tasks. And here's what happens. The AI passes those commands right along to the powerful MCP server, which does exactly what it's told. It finds the secret file and copies it to a new branch that the attacker can get to.
The really crucial thing to understand here is that the security breach happened by exploiting trust, not by hacking code.
So, does all this mean MCP is just too dangerous to use? No, not at all. It just means the future isn't about throwing the protocol away. It's about taming it, about building the right guardrails around it to make it safe.
So how do we actually build a more secure system? We can tackle these risks with real enterprise-grade solutions. We can use allow lists, so only pre-approved tools are even allowed to run. For high-risk stuff, we can require a human to sign off on it. We can taint data from sketchy sources to track where it goes. And, this is critical, we use very specific, narrowly scoped credentials instead of giving these things God mode permissions.
So the main takeaway here is pretty clear. Big companies aren't going to be using the pure open version of MCP. They're going to use a hardened version, one that's wrapped in thick layers of governance, security, and control. MCP provides the standard for the connection, but the enterprise has to build that crucial framework of control around it.
And that leaves us with one final, really critical question. The Model Context Protocol does a brilliant job of standardizing the connection between models and tools. But as this whole new ecosystem explodes, the next huge challenge is going to be who is going to standardize the security?